Friends, as I have explained you in the last class, limit of the function f of z, which is z by z bar, which is equal to, we will discuss in two manner. Say case 1. In the case 1, as we are approaching the limit z tends to 0 through real axis. In that case, imaginary part of real number is 0. That means y is equal to 0, as you know that here. So then that limit becomes x plus I into 0 divided by x minus I into 0. That is, as extending to 0, x and x get cancelled there, as shown there, you will get it is 1. That means you will get limit of the constant 1, it is nothing but 1 itself. So we have got that as z tends to through real axis, we have got the limit value 1. In the same manner, as z tending to 0 through imaginary axis, that means you are letting your limit through imaginary axis. In that case, real axis, real part of the term is 0. That means here you have to consider x equal to 0. So y term only remains. So in the limit z by z bar, that is equal to limit y tending to 0 now, 0 plus iy divided by 0 minus iy, which on simplification you will get minus 1. See, now you observe that as the limit you are approaching through real axis, you have got the value 1, and through imaginary axis you have got the value minus 1. The two approach values are different, therefore we will say that limit of the function does not exist. So it is not guaranteed that limit of a given function always exists. Now we will observe another concept in the set of complex number. It is continuity of a function. As you observe that in the set of real numbers, continuity how you have defined in the calculus, that is a function f of x is said to be continuous at a particular point, say x is equal to a, 1 if 1 limit of the function exists, second the function value exists at that particular point, and the third one, the function value, that is f of a is equal to limit of the function, then we will say that the given function is continuous in the set of real numbers. If any one of the three conditions does not satisfy, we will say that it is a discontinuous function. In the same manner, in the set of complex number, we are also going to define continuity of a complex number. Here it is function is f of z. Now a given function that is defined from set C to C, there it is said to be continuous at a particular point. Point is taken it as z naught here, if and only if the function value of that function that value is exist. That exist means it is defined. Second condition, limit of the function it should exist. In the third condition, both of them, first condition is equal to second condition. That means f of z naught is equal to limit of f of z as z tends to z naught, they should be equal. Then we will say that the given function is continuous function. If any one of that condition does not satisfy, we will say that it is a discontinuous function. As you have studied in set of real numbers different properties of continuity of a function, here also limit of the sum of two continuous function is continuous function. difference of the two continuous function is continuous function, product of the two continuous function is continuous function, and quotient of two continuous function is continuous function, provided denominator g of z should not be equal to 0, or we'll say it must going to define that, then we'll say that it is a continuous function there. Now, after studying the limit concept and continuity of a function, I mean set of complex number, we are going to study the fundamental idea is differentiation of a complex number or derivative of a complex number. As you have studied in set of real numbers, here also we can define derivative or differentiation of a complex number. How it is going to be defined, that I have explained in the board. You are given a function f of z, it is a complex valued function. You are defining at a neighborhood of a point, then the derivative of f of z at z naught is nothing but limit of f of z naught plus delta z minus f of z naught divided by delta z, as delta z tending to 0. If that limit exists, then we will say that derivative of the function exists, and we will denote it by f dash of z naught. Now, corresponding to this, we have the sum rule, difference rule, product rule, quotient rule and chain rule in the derivatives. F plus g or minus g, derivative of that at a particular point z naught is equal to f dash of z naught plus g dash of z naught, and product of the function is if you are given two complex numbers, that here it is complex, I mean complex function, that here it is, then how to find the derivative? Here it is going to be explained with the help of product rule as defined in set of real numbers. That is, first function f of z as such, you are differentiating second function, say g of z at a particular point z naught plus again second function as it is g of z keeping as such, you are finding out derivative of first function at that particular point where you are going to want the derivative. So, that this is the manner you are going to define. Again, the quotient of the two function f of z divided by g of z, if you are interested to find the derivative, we are going to define with the help of quotient rule as you have defined in set of real number, that is equal to, you are drawing a denominator there, that is g of z whole square. In the numerator, denominator you write as such g of z naught particular point into derivative of numerator minus, you keep numerator as such, f of z as such, you differentiate denominator, that is g dash of z naught, provided that g dash of z naught should be defined here. So, this is what which is shown in the board, set of formulas will say that while solving the derivative of function problem there. Similarly, as you are defined in chain rule, if you are given a function of function, then how to find the derivative, which is nothing but using your chain rule, and that we will see in the next class. Thank you.